Logarithmic regression is used to model situations where growth or decay accelerates rapidly at first and then slows down over time. You use the command linreg on a graphing utility like a TI calculator to fit a logarithmic function to a set of data points. This returns an equation in the form y equals a plus b natural log of x. Note that all input values x must be non-negative. When b is greater than 0, the model is increasing. When b is less than 0, the model is decreasing. And in Desmos, what you'll see in a moment, I do y1 tilde a plus b natural log of x1. So due to advances in medicine and higher standards of living, life expectancy has been increasing in most developed countries since the beginning of the 20th century. The table below shows the average life expectancies in years of Americans from 1900 to 2010. So there's our data set. We see it going from 47.3 to 78.7. Let x represent time in decades, starting with x equals 1 for 1900, x equals 2 for 1910, and so on. So when I index this, that's 1, it goes up to 12. And then it wants us to use the model to predict the average American life expectancy for the year 2030. Okay, so let me go ahead and bring this over. I did type the data in, so sure you don't need to see me do that. It looks like I still fall within the screen. Okay, so you see the data plotted up here, and it's going along. It looks like it is kind of curving out, kind of reaching, heading towards an asymptote. And if I did the y1 tilde a plus b, let me see if I can, I don't know if I could slide this over, I don't think I can. bx1, natural log x1, excuse me. I turn that on, there's our curve. Look at that curve. Pretty good curve. So the A would be 42.5272, the B would be 13.8575. That R value, yeah, it's not a bad R value, 0.9563 is for the R squared. So if you take the square root, the R value is going to be better than that. So, okay, let's see. Let me drag this out of the way, and we'll do some math to see what it would be in 2030. And in 2030, we'd be looking at an x of 14. So we want x to be x equals 14. Our equation is going to be, I think I called it still y, didn't I, up here? Yeah, y. I like to use a, the amount at time t. It's going to be 42.5272 plus 13.8575. That's a point. Natural log of x, or t, I guess in this case. So the amount at 14 would be 42.5272 plus 13.8575 natural log of 14. And I'll put this in my calculator and see what we come up with. What is the life expectancy in the year 2030? And I come up with 79.0979. So we'd say, and that's actually an approximation because it goes on forever, 79.1 years. Okay. That's doing the logarithmic regression.